Yeah, warm good morning to all. Uh, as a part of our video lecture series, today we're going to see a case study on the failure analysis of welded flanges. Uh, Here you can see before going to see this case study, which is on a general based on failure analysis, we must know what has actually happened and when it has happened. The first one is that it has happened in January 1998 in Belgium. Here the component is with the coarse grain microstructure, which was installed in a high density polyethylene loop reactor. So the dimension is phase 101 millimeter, thickness is 24 inch, and the material is A 105 carbon steel. Here you can see in the visual examination in the figure 1, we can see it is a crack in a transition region between the conical and the here this is the between the conical and the circular shape, circular cylindrical part, and figure 2 it is it's coincide with the cold area. When we do the metallographical analysis, this original 24-inch flange from a HDPE reactor have not been normalized correctly. Here the normalization is normalized means it's a normalization process. The normalization process means here the material should be heated up to a particular temperature, the hold in a particular temperature. That is for a steel it is about 900 degrees Celsius, and it is cooled in an open air. So the cooling here the cooling will be fast because of the particular component is cooled in a still air. Okay. Resulting in the here there's no normalization. Here it is not normalized correctly, resulting in the coarse grain microstructure. So the next one is the difference between the maximum and the minimum individual ASTM grain size is measured as 1.3 to 2.3. Here the microstructure of this broken 24 inches, that you can see the cracks here. It is investigated same as it is shown before. The next one is that see, this is the crack which is magnified here. This is the crack, you can see it is magnified. See, this is the crack here. The crack is due through grains. So when we do the chemical analysis, we can see it is the main components like carbon, which is maximum 0.35%, silicon, manganese, and copper and nickel, which is on in the proper proportion. Here, in mechanical testing, you can see this transition temperature corresponding to such flanges in a main impact of 27 joules is about plus 20 degrees Celsius, and the minimum operating temperature is minus 29 degrees Celsius as allowed by the ASME, which is American Society of Mechanical Engineering, B31.3, and the flange possesses an impact toughness of less than 10 joules. The next one is that here it's an here on having this in conclusion is that in a metallographic examination it is concluded that the 40% of the investigated flanges has not been heated properly. Due to this, there won't be a homogeneous microstructure throughout, but instead there will be the microstructure distribution, or the proper microstructure distribution is not happen properly. So after forging, despite of this company certificate, all flanges should be normalized. So when the normalizing is done properly, you can see the material is heated, hold at a particular temperature, and cooled in the still air, so that the cooling will be faster, so that fine grains will be formed. This fine grains, which in turn helps to have the high strength. There is evidence that it's a coarse grain microstructure and the presence of Weizmann standard ferrite, and the carbon equivalent is ranges from 0.36 to 0.47, but here it is higher than the carbon equivalent which is indicated as a certificate. The second is that it is concluded that the first important conclusion in that many cases that data of the structure do not comply with obtained test results, which means the data mismatch happens. And the second one is that the certified heat treatment is incorrect, or it is not performed properly, which results in the large grain size and poor toughness, that too in the coarse grain manner. The recommendation is that the ASTM grain size number in the present investigation is 8.6 or 9.4, 8.6, but it should be 9.4. and toughness should be respectively between minus 10 degrees Celsius to minus 29 degrees Celsius. And it is recommended to perform an ultrasonic as well as replica examinations for all flanges before putting them into service. That's all for today. Thank you.